Hello, everyone. Welcome. Today I'm going to teach you how I analyzed 33 million bike trips with BigQuery. Feel free to come. There's some seats in the front. Don't be shy. A little bit about me. My name is Sara Robinson. I'm a developer advocate on the Google Cloud Platform team. I'm based in New York. It's my first time in Oslo. I'm super excited to be here. You can find me on Twitter at srobtweets. And as a developer advocate, my job is to teach other developers how to use Google Cloud Platform products. I focus on big data and machine learning, and I do that through demos, talks, and online content like blog posts and screencasts. Before I dive in to how I analyze the data, I'm going to start with a story. So up until about a year ago, I was terrified of riding bikes for no good reason, really. I just liked having my feet on the ground. But I moved to New York, and I saw these city bikes everywhere and decided to give it a try. There was lots of nice paths in New York, and I really enjoyed it. So slowly I became a little bit less afraid. And as I started to use City Bike, which is New York's local bike share program, more, I started to notice that they had stations everywhere. Every couple blocks in all the boroughs of New York, there's all these bike racks. And I noticed that at different times of day, they were more active than others. Some people were using them to commute to work. Other people were using them just to get exercise. Tourists were using them to see things like Central Park. And obviously, there was different factors that affected when more bikes were being used. For example, you can see this picture in the middle. Obviously, when it's snowing, not very many people are going to want to ride the bikes, so the dock is completely full. So as I started using city bikes, all these questions came to my mind. So I wondered how many stations there were and how many bikes were in circulation at a given time. Like I said before, I wanted to know how different factors affected whether more bikes were being used. I wanted to know what the most popular routes were, if people were riding pretty unique routes, or if there were certain routes that tons of people were riding frequently. And City Bike has a subscription system where you can pay an annual fee, and you basically get unlimited access to use it. Or if you just want to use it on a one-time basis, you can buy a 24-hour pass or a 3-day pass. So I wanted to see if people that had the annual subscription were using it differently than people that just had a 1 or 3-day pass. Also wondered, do men and women take the same bike routes? So tons of questions came to mind, but without any data, these are pretty tough to answer, right? It might be like a tough interview question. How many bikes are in circulation in New York at a given time? We could come up with a pretty rough estimate, but there's no way to know if we'd be exactly right. So I was really excited to discover that City Bike provides data on every trip that's been taken since 2013, and this is publicly available. So anybody can go and download these CSV files and do anything you want with the data on every trip. So CSV files look something like this. That's a lot of text, I know. Breaking it down for one entry, we get data on the bike ID. So each bike in the system has its own unique ID. We get the start time and end time of the trip, the ID, name, and latitude and longitude of the start and end stations. And we also get some additional data. We get the duration of the trip in seconds, which is what this number is. We get whether they're a subscriber or what they call a customer. A subscriber pays the annual fee. A customer is just using it on a one-off basis. And if they're a subscriber, we have data on their age through their birth year and then their gender. So I wondered, I have all this CSV data. How can I analyze it? And since I work on the Google Cloud Platform team, I chose to use BigQuery to do this. BigQuery is essentially our big data as a service tool for Google Cloud. It's completely managed, no ops. It's a big data analytics warehouse. So you upload your data to BigQuery, and you can query it really, really fast. It's great for large sets of data. So you can query terabytes of data in seconds. Towards the end of my presentation, I'm going to show you a terabyte query. And all the queries are written in familiar SQL. So you can do it via the web UI. You can also write queries via BigQuery's REST API. And we have a number of client libraries that support that in many different languages. And if you're not familiar with SQL, BigQuery also integrates with a number of third-party visualization tools like Tableau, Data Studio. I'm going to show you some of those today. One of my favorite things about BigQuery is that you can share your data really easily right away. So you can share your data at a dataset level. So a dataset contains multiple tables. You can share your dataset with just one person via an email address or a group email alias, or you can share it publicly to all authenticated cloud users. And if you want to try it out, we have lots of public datasets available, and you get a free monthly quota, so you can query up to a terabyte of data for free every month. We recently announced a free tier for storage, so you can store up to 10 gigabytes of data in BigQuery for free. So that's a quick overview of what BigQuery is. So the first step was I found all this CSV data. I needed a way to import it into BigQuery. I'm going to show you how I did that. Once it's in BigQuery, I wanted to analyze it. We get a ton of data on every trip, so lots of possible different ways to analyze the data. And then finally, I wanted to visualize some of the data, because BigQuery gives you this nice table output, but sometimes it's easier to digest this data in the form of a visualization. So the first thing I needed to do was import the data into BigQuery. And what I did was I downloaded all those CSV files, and I put them in Google Cloud Storage. That's just one way to import the data. And I am a big fan of Node.js, so I used the Node client library to import the data. And all I needed to do was create a reference to Google Cloud Storage, get the files from my storage bucket with all the trip data, and then I call this function create BigQuery table, which I'll show you on the next slide. And so here, using the client library for BigQuery, it's really easy to import these CSV files in. I just need to define my schema, call dataset.createTable, give it some data about what the format is of the data that I'm importing, and then I can call table.import. All my bike data is readily available to query in BigQuery. This is just one way to do it. You can also import data via the web UI. So if you have just one or two files, the web UI is super easy to import data that way. Because I had a file for every month of bike data, I decided I would write a script to automate that. So I use the REST API through the Node client library. There's many other client libraries available as well. You can also use Cloud Dataflow, which is our batch and stream processing service. So you could pull data from BigQuery, do some processing on it, output it to another BigQuery table, or a number of other sources. And finally, you can link Firebase Analytics to BigQuery. Firebase Analytics is a mobile analytics platform, so anybody that's building a Android or iOS app using the Firebase SDK, which Firebase is a backend platform provided by Google, you can link your application to BigQuery so that you can automatically stream all this analytics data about your users. You can create custom analytics events, and you can send it to BigQuery to do all sorts of custom analysis on your data. So many ways to get your data into BigQuery. But now that our bike data is in BigQuery, I want to analyze it. So I'm going to walk you through a bunch of the queries that I ran, along with some of the visualizations I created on the data. So first things first, this is what the BigQuery web UI looks like. And we can write our queries directly in the browser. So I'm looking here at the city bike trips table. This table is publicly available. It's part of the BigQuery public data project. So this is what our schema looks like. And once this loads, we'll be able to see what a row looks like for each trip. Each row represents one trip. So we get the duration, the start and end time, some information about the start and end station. We get the bike ID, the user type, and for all subscribers, we get data on their birth year and gender. So I can query this directly in the browser. And the first thing I'm going to do is I'm just going to do a count star to count how many bike trips there were. We can see that, you already knew this from the title of my talk, but there's 33 million bike trips that have been taken since City Bike started in 2013, which is a lot. We probably want to do something a little more interesting than just count how many rows are in this data set. So the next thing I wanted to look at was the number of bikes in New York over time that were part of the City Bike system. Make that a little bigger. I'm going to run this query. And we should see for each year how many bikes. So when it started, there was about 6,500 bikes. And we can see that this gradually increased up to a little over 10,000 bikes in 2016. Now let's say we wanted to, instead of just looking at the data in this table format, let's say maybe the data is more complex, and we wanted to instead visualize it. So what I'm going to do is I'm going to use a tool that's provided by Google called Data Studio. This is the home page, and I'm just going to create a new report from scratch. So I'm creating a new Data Studio report, and it's going to ask me to create a new data source. So I'm going to choose BigQuery and make that a little bit bigger so you can all see. And I'm going to write a custom query. I need to link it to my project, and I'm going to paste in that query here. It uses standard SQL. And so when I connect this, I'll have all the data you saw right here available in Data Studio to visualize. So we've got that here. I can add it to my report. And let's say I'll do a bar chart. I'm going to put it right here. And we automatically have a nice bar chart of our data. I'm actually going to sort it by year, ascending, so that we can see how the number of bikes increased per year. So really easy to integrate BigQuery with other data visualization tools. And if I put it in view mode, we can see that I now have this nice interactive chart. It's just one example of how easy it is to visualize data in BigQuery with a number of other tools. So the next thing I wanted to look at was what were the most popular stations in New York. So here I'm going to get the 10 most popular stations. I'm going to get their name. These are the start stations, so the most popular stations for people to pick up a bike. And we can see here that we get the start station name, the latitude, longitude, and the number of trips. We're ordering here by number of trips. Now again, it's nice to see this data here, but I don't know about you, but I can't look at a latitude and longitude and picture where that is on a map. So it'd be nice if we could map this data. And to do that, I used a tool called Cardo to create my maps. And all I needed to do was I clicked this download as CSV button in BigQuery. I didn't do the limit 10, I just looked at every single station. And then I went over here to Cardo, and I'm able to create this heat map. So the darker red dots show you stations with the most trips, and I can hover over them and see Fifth Avenue and 29th Street had 131,000 trips in total since the program started. So I can create this nice interactive map, and I can see that the lighter stations, like over here in Brooklyn, are fewer trips, maybe they're newer stations. Obviously, the stations with the most trips are in Midtown and downtown. So just a nice way to visualize latitude, longitude data that we get from BigQuery. The next thing I wanted to look at was trips by member type. So I told you that there's two types of members. There's subscribers who pay the annual fee to have almost unlimited use of the bikes. And then there's people that just use it on a one-time basis. So I looked at all the trips just in 2016 by member type. And what we find here is pretty interesting. So the subscribers account for a much larger portion of the trips. 9 million trips taken by subscribers in 2016, compared to 1 million trips taken by people that are just using the bikes on a one-time basis. But with the subscribers, we see that their average trip duration is much shorter than the people that are just renting the bikes on a day, which makes sense. You're probably, if you're visiting New York and renting a bike, you're probably using it for sightseeing, rather than if you're a member, you might be using the bike to commute every day. So I'm also going to visualize this in Data Studio. So if I go back to my Data Studio report, I go to Edit, and I'm going to create a pie chart. But I will need to define a new data source. So I'm going to say create a new data source. I'm going to do the same steps that I did before. So I'm going to do a custom query, link it to my project, and connect that. And then I should be able to generate a nice pie chart showing me the number of trips by subscribers versus customers. So I'm going to disable that field. We're not going to use duration in this example. And just need to tell it to sort by user type, and then the metric is going to be number of trips. And there we get a chart to show you that subscribers account for 88% of all trips taken in the system. So then I can, again, go back to view mode, and I can see that nice interactive pie chart. So the next query I want to show you, let's see where we left off, is right here. So continuing with analyzing by member type, the next thing I wanted to do was look at the routes that different types of members took. So if I wanted to see if there was common routes that a lot of people were taking. So I'm going to go ahead and run this. And I also wanted to look at the average trip duration for those routes. So what's interesting here is that even though the customers accounted for a significantly less portion of total trips, they're doing the exact same route. So the most popular route is Central Park South to Central Park South. So you notice that the start and end stations are the same here. So they're just picking the bike up, doing a nice little tour around Central Park, and then bringing it back to the same place they got it. And the top 3 trips have the same pattern of the start and end station being the same. And you'll notice that they're renting the bikes for a long period of time, Even though when you're just renting the bikes, you get 30 minutes, you can spend longer, you just have to pay a fee for that. But they're spending a lot more than 30 minutes on the bikes. The first route we have by subscribers is only 5 minutes in length. And then we have another one by customers. Again, the start and end station are the same. So we can see really different types of usage patterns between these different member types. And going to my next query, I wanted to look at the gender and age data that we got from City Bike and see what the most common ages of people using the bike were. And we can see here that 31 is the most common age. There has been about 1.2 million trips taken by 31-year-olds. And we can see that men are using the bike significantly more than women in New York. And again, this data would be a little nicer to read if we could visualize it. So for this visualization, I use a tool called Exploratory. It's a third-party tool. It's just a desktop app. And again, I downloaded the CSV and imported that to Exploratory. And I'm really easily able to visualize my data. And I can create public graphs and share the URLs for them. So we can see here that indeed the orange shows women, blue shows men, and we can see that 31 is the most common age, and we have riders as young as 16 all the way up to 90, which is pretty cool. So big age range of riders, although they're mostly concentrated in this 30 to 45 range. So that's another way we can visualize our BigQuery data. And diving further into looking at routes by gender, I wanted to see, grouping by gender, what were the most common routes. So I looked at only 2016, and I first wanted to see the top 5 routes by women. So I get these routes here, and I wanted to compare this to the top 5 routes by men. Initially, I thought this would probably be very similar. I didn't expect very different usage patterns here, but if I run this query to look at the top 5 routes by men, you'll notice that they're completely different, which I thought was really interesting. So I wanted to map that. Again, this is just in 2016, so there's not so much data for total trips here, but we see that it's completely different. And so I wanted to look at this in Cardo. So what I did was I mapped the top 10 routes. So the purple routes are routes by women, the blue routes are routes by men. So what's interesting here is that we can see that women are riding for a bit longer. This is more of a scenic route along the river. Men are maybe using it more for commuting, and their usage is concentrated in this area, which is near Grand Central Station. So maybe it's people that are commuting from outside the city, then getting out and using a bike just to get to work that way. We can see that women are using the bikes more outside Manhattan in Brooklyn down here. So another way you can use Cardo and to actually map routes. And the way I use Cardo here is it has a tool that will give you, if you give it a start and end point, you can choose either the walking, biking, or car route. So that's how it's able to map the routes here, instead of just drawing a straight line between start and end. So the last animation, the last visualization I wanted to do is I wanted to find the bike ID that has taken the most trips since 2013. So I'm going to run this query, and we'll see that bike number 17526 is the winner. I think they should paint that bike gold or something. It had 5,500 trips since 2013. So that piece of information isn't so interesting on its own. So what I did was I ran a query to get the start station latitude and longitude for every single trip that bike has taken. And Cardo lets you do animations. So I'm going to play the animation now. You can see the date right here. So it starts in July of 2013. And we can see how this one bike travels throughout the system. And you'll notice that we're in September now. When we get to the winter, you'll see it kind of drop off for a bit. December kind of goes quiet. Even though the system is still in operation, people don't really want to ride in the snow. But you can see how this one bike is just traveling throughout the system, which is cool. I won't play the whole thing. It goes all the way through 2016. But the way I did this is I just imported my CSV file into Cardo, and you just give it a data point to animate on. So it animates by time, and we can see the stations change as it progresses from 2013 to 2016. So that is all of the bike queries that I have, but I'm going to go back to my slides. and show you a little bit more data analysis in BigQuery. So I showed you how we visualized our data using a number of different visualization tools. So we had Carto, Exploratory, and Data Studio at the beginning. We do have a number of other public data sets in BigQuery, and you can query all of these for free using your free terabyte each month. And one of those is about a year ago, we put all of the open source code on GitHub into BigQuery. And this table is massive. It's almost 2 terabytes, which is a lot. This is a table that contains the contents of every file on GitHub in the head branch. So it's a lot of data. And using Data Studio, this is a visualization of the languages by bytes and then by repositories. So by bytes, C accounts for 63% of the code on GitHub, whereas if we look at by repositories, JavaScript has the most with 14%. So what I wanted to do, since this is a .NET conference, I want to find all of the CSharp files on GitHub. So I'm going to copy this query, and I'm going to go over here. And what I have here is, this is the data set that contains all the GitHub data. So here I have the files table, and the files table is about 330 gigabytes. It's updated continuously to add new code. And the files table gives us the repository name, the ref, the path of the file. And then we have this ID, which we can join with the contents table. So the contents table is that giant table, 1.9 terabytes, which has every file in the head branch. So the contents of every file, which is pretty crazy. If you're playing with this data, I recommend using these sample tables so that you don't use up your free monthly terabyte right away. So you can play with the sample tables. They have about 10% of the data. And then once you find out what you want to run your query on, you can use the full table here. So we're going to go to the files table, and we're going to use standard SQL, and I'm going to paste in that query here. Any guesses? I'll run the query first. And you can click on this validator here, which will tell you exactly how much data your query is going to process, and that's what you'll be charged on. So you can kind of get an estimate for it before you run the query. Any guesses? Number of files, C# files on GitHub? I'm going to run it. So here we can see that there is about 18.8 million C# files on GitHub, which is kind of crazy. There's a lot. But I wanted to do a little bit more complex query here. So on the next slide, I wanted to find out what were the most popular NuGet packages on BigQuery, on GitHub. Sorry. So I'm going to copy this query. I'm going to go back here, and I'm going to not use cache results to show you that I'm not cheating. So this query will process 2.1 terabytes when it runs. So because this is going to take a bit of time to run, I'm going to run it and then explain what's happening. So I'm going to run that query. So what we're doing here is we're getting all of the packages.config files, all of them from GitHub, and we're getting the contents of those files. And then we have a regular expression here that just gets the ID of all the package names from those files. So it's running now. And again, this is running over every single packages.config file on GitHub. And then we're just going to count how many times that package occurs and order it by the count. Should be finishing up soon. There we go. Looks like it's done. It's done. So Newtonsoft is the most popular. We can tab through it to see if this is what you expected. You can see some of the most popular ones. So that's just an example of type of analysis you could do using the GitHub public data set on BigQuery. Now, again, we have a lot of other public data sets that I haven't showed you here. You can see just a few of them right here. An interesting one is the weather data. So we have weather data from every year since 1929. So something I haven't done yet, but I would like to, is find the weather data for New York and join that with the bike data to see how rain and snow affects bike trends. So I definitely recommend checking out the other public data sets we have available. Another fun one is all Stack Overflow questions and answers. So I'm going to go back to the slides. And lastly, I've got one more thing for you. So what about Oslo Bicycle? New York data is interesting, but we're in Oslo right now, so some of you may not have even been to New York. Oslo Bicycle has been around for about a year, so it's a local bike share system here. I tried it out yesterday. Here's proof that I rode a bike. And I put they also provide public data, and I put it all in a public BigQuery table in my personal project that you can access. So I'm going to show that to you now. So it's available if you go to this bit.ly link. I'll show it again at the end. You can all go query it, create your own visualizations. So right here it's in my personal project, Sara BigQuery. We've got data on all the trips taken since it started in April of last year. Now, they don't provide as much data on each trip as the New York City bike, but maybe they'll add more in the future. So we have the start station, start time, end station, end time. Data looks like this. And they also provide station data, so I went ahead and put that in a separate table. So you can join this to get the latitude and longitude of the start and end stations. And we also get data on the number of docks at that particular station. So we can see the name of the station, the title, the number of locks, and then the latitude and longitude. So what I did was I created a Data Studio visualization. This is pretty much what you'd expect. So I looked at the number of trips by hour for all stations around Oslo. And we can see that, commuting times, this makes sense. So around 8 a.m. it peaks at 23,000 trips per hour. And at 4 p.m. we have another peak. And then I looked at the most popular station, Akerbrugge. I may have mispronounced that. I tried. Looks pretty similar to this graph. And this is just in May 2017. I created another map using Cardo to look at the most popular stations in Oslo. So we can see here that the darker red ones are, I'm not even going to try to pronounce that one, are the most popular stations. I think we have the Akerbrugge station over here. So 52,000 trips on that one. And then we can see there's some newer stations on the outskirts which have had fewer trips. And then one thing I did was I created an animation. So I looked at one day of Oslo Bicycle on May 1st, last month, all the trips that were taken in one day. And the time here I think is a little bit off because it's in UTC, but you'll see in a day, these are all trips happening, and you'll see that you can tell what the rush hour times are. We can see more and more trips happening throughout the day. People slowly making their way to the outskirts. So I encourage you all to check out the Oslo Bicycle data and create your own visualizations, see what you can do with it, and definitely let me know if you create anything interesting. I would love to see it. So now I'm going to go back to the slides. And this is a link to the map that I created if you're interested to see that heat map of the most popular stations. And that's all I've got. So I wanted to end with just sharing you all the resources that I talked about today. If you want to learn more about BigQuery, there's lots of quick start guides, documentation. There's a CSharp client library. One thing I did forget to show you, I'll go back to this slide. I wanted to show you how I ran these queries in CSharp. So I use the BigQuery client library for CSharp. So I've got Visual Studio open here, and I just wrote 3 of the queries that I showed you before. So if I go here to run the program, we should be able to see my queries outputted here. So I'm just showing you the query I'm running, and then we're outputting the results. Just showing you 3 of the queries. So really easy to do this in CSharp.net. Totally forgot to show you that before. And if you want to find out more about the CSharp client library, it's right here, bit.ly/bigquery-C#. If you want to check out the New York City Bike Data, see what other types of visualizations you can create from it, there's a link to that there. Definitely interested to see what you all come up with the Oslo Bike Data. And I wrote a blog post about how I analyze the New York Bike Data, showing similar queries that I showed today. So if you want to see it in written form, you can check out that on the Google Cloud blog. And thank you for coming.